coming back here, we've got a p-value of 0.16. Okay, is that a big p-value or a little p-value? It's big, because I actually haven't got as far as this very much. It's bigger than 0.05. It's not low. So p-value equals 0.16. So what it means is there is a 16% chance of getting a result is different from the expected. It's not quite, this is not totally rigorous, but once you get totally rigorous, it's incomprehensible. Different from expected as this if the null hypothesis is true. Okay, so what that means is if there really is no relationship between how successful people have been at maths and how useful they think this course will be, if you think don't reject. Okay, the don'ts are correct. Do not reject the null hypothesis because the p-value has to be lower than this for us to reject. 0.016 is greater than 0.05. That's in brackets. And if we were going to write a sentence, we could say there is not evidence to say that there is a relationship between blah, 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 whatever it was we said to begin with. So that's how you do the 5 steps. So I'd expect you to be able to write your hypotheses and decide whether to reject the null hypothesis or not, and write out what it means. So what does it mean? What it means is that though we thought people who were successful or thought they'd been successful in the past would think this is more useful, there doesn't seem to be a relationship, or there is no evidence of a relationship in our data. Okay, but we can be wrong. And in fact, we can be wrong quite often. And with an alpha value of 0.05, how often are we supposed to be wrong? Anyone? 5% of the time. 5% of the time when we reject the null hypothesis, we will do so by mistake. Which is not a nice thing to think about, but it's just how it is. And if we reduce it, then we run into the other kind of error.